Okay, here we are, cranking out the answer key for the practice test. We are just going to be super careful and do this in real time. Hope I don't make a mistake. This vector in rectangular form is just going to be over 1 and then down 3. Just make sure you count carefully. Use your fingers, take off your socks and shoes if you need to. Y is over 3 and up 3. Does not matter where these arrows are drawn. I could have just as easily drawn this here and it wouldn't have made any difference. It's about where it starts and about where it stops. So when I add these, I'm going to add the x components and get 4. I'm going to add the y components and they cancel and I get 0. So adding these two vectors would be no different than just moving 4 over, up and down, nothing. Double the first one and I get 2 minus 6. Subtract 3 from 2 and I get negative 1. Subtract 3 from a negative 6 and I get negative 9. So just be super careful when you do your addition and subtraction, especially with the negative signs. Okay, now it says graph the following vectors given to you in polar form. So just to graph them, if I'm 8 and 5, I could say that's 5, that's 10. 8 is about there, but it's at an angle over of 120 degrees. So it's something like that. You don't have to be super accurate, but that would be, we could say this equals A, and there's A. You can label them however you want. I don't even think it's a huge deal if you don't label them. It'll be pretty clear, but I guess you should. 5 and 45 degrees is going to be this long and exactly halfway between the right angles. So that's pretty much what that is. There's vector B. Okay? So then add them. So if I add them, I'm going to pick this one up and put it down right here, or I'm going to pick this one up and put it down right here. You should get a parallelogram no matter what, and I'm going to be approximately right there. So my dotted line represents my resultant vector, and you can label that. Maybe make a better arrowhead than I did, resultant. And I will try to give you a little bit bigger graph to use on the test. But you can make do. Anyway, now we're going to add them and write the resulting vector in polar form. So I convert these into rectangular by doing, in rectangular form, it's going to be 8 cosine of 120 degrees, comma 8 sine of 120 degrees. And crunching those numbers, you're going to get negative 4 and then 6.93 rounding to the nearest hundredths. That's for vector A. For vector B then, doing the same thing, it's going to be 5 cosine of 45 degrees and then 5 times the sine of 45 degrees. So the y is always the sine, the x is always the cosine, and I'm going to get 3.54, and then because it's a 45 degree, it's also going to be 3.54. So there they are converted into rectangular form. Now I'm just going to add the x's and add the y's. So when I add a negative 4 and a positive 3.54, I'm going to get a negative 0.46, and 6 and 3 is 9, 10.46, I believe. And there we go. So that is the resulting vector in polar form. In polar. But now I want to convert that back into rectangular form, so I do the Pythagorean thing. I square this, 0.46 squared plus 10.46 squared. I square root that, and you know this decimal, sorry I've written over that, is really not going to change this much. When you take the square root, I believe it's 10.47. That should not surprise you that this right triangle is very, very slim. It's only going to increase the length of the hypotenuse by a very small margin. That's the radius. But now theta, let me do that up here. Theta is, well, it looks to me like it's in the second quadrant. So when I make that right angle, it's going to be the opposite side. So it'll be the inverse tangent of the opposite side, 10.46 over 0.46, drop the negative sign, And when I do that on my calculator, I don't know if you can see it, but I'll do a second tangent, inverse tangent of 10.46 divided by 0.46, close parentheses, hit enter, and I get 87 degrees, 87.5 degrees. So if theta is equal to 87.5 degrees, in my angle of rotation is going to be 180 minus 87.5 degrees. So that's going to be what, 92.5 degrees. So there's my radius. So my final answer is going to be 10.47 comma 92.5 degrees. Very close. Don't worry if your answer is slightly off. Alright? Finally, what is a bearing and how is it similar to polar coordinates? To save you having to watch me write this all out, a bearing is based on north and is rotating clockwise, CW for clockwise. Polar coordinate is based on a horizontal and is a rotation counterclockwise. Okay, but both of them have to do with measuring by an angle and a direction. Bearing really is only about which way you're heading, whereas polar coordinates is really about a length and a heading. So you can plot a point in polar, but it's harder to plot a point with a bearing. It's more about which way you're aiming. Okay, that's a good first page.